Hi all. In this lecture video, we are going to see about the continuation of input-output system. Now we are going to discuss about the topic called as application input-output interface, that is kernel input-output subsystem. So let me again tell you the agenda. We already saw about overview input-output hardware, and in this we are going to see about the application input-output interface. Let me discuss the definition first. What is the purpose of this application input-output interfaces? Normally, input-output system calls that actually encapsulate device behaviors in generic classes. So, what is the purpose of device driver is? Device driver, it is actually a layer which hides differences among input-output controls from kernel. So normally each operating system will have its own input-output subsystem structure and device driver frameworks. Devices vary in many dimensions: character stream or block, sequential or random access, synchronous or asynchronous, shareable or dedicated, speed of operation, read-write, read-only and or write-only. A kernel input-output structure. When we study about the introduction about operating system, we have studied about the structure of the kernel, how a kernel will be. So the same case here, kernel is actually a software. Kernel input-output subsystem is there, which have SCSI device driver will be there, keyboard device driver is there, mouse device driver is there. And similarly, we have, if you see in the hardware side, we have SCSI devices, keyboard, mouse, PCI bus, floppy disk drives, etc. So, what are the characteristics of an input-output devices? We have three columns here. One is aspect, variation, and example. If the aspect is data transfer mode, if it is in data transfer mode, the variation here is character block, and the example is, I can say about terminal disk. If it is access method, we will follow the sequential random access. Two access methods are there, sequential and random. The example is modem or CD-ROM. If it is transfer schedule, we have synchronous, asynchronous, tape or keyboard. So similarly, we have device speed. If it is speed, it meant for latency as well. Seek time we can calculate, transfer rate, delay between operations. And if it is IO direction, we speak about read, write and read, write. For example, CD-ROM, graphics controller, disk. What are all the characteristics of input-output devices? The continuation. Broadly, this input-output device can be classified or grouped by the OS into block input-output or character input-output, memory mapped file access or network sockets. For manipulation of input-output device, specific characteristics, usually an escape or backdoor. We are going to use a function called IO control, which is used to call to send arbitrary bits to a device control register and data to device data register. Block and character devices, which is the first input-output devices. What actually this block device include is disk drives. The commands generally they will use is read, write, seek, raw input-output, direct input-output or file system access, etc. And character device includes, keyboards, mice, serial ports. The commands which they include is get, put, etc. And we have network devices. Networks itself, they will use sockets for the transformation. So separate network protocol will be there, and they will use the select functionality. The approaches can be very widely for the following things like pipes, FIFOs, streams, queues, mailboxes, etc. Which are all the OS use sockets is Linux, Unix, Windows, all the things which use socket interface for transformation. Clocks and timers. To find seek time latency, we need clocks and timers, so which provide you current time, elapsed time, timer, etc. There is a thing called as programmable interval timer, which is used for timings periodic interrupts. Non-blocking and asynchronous input. We have three things: blocking, non-blocking, and asynchronous. Two IO methods are there: synchronous and asynchronous. So let me continue with the other topic in the next video.